Welcome to this technical explainer. We're going to jump right in today and demystify the entire process of AI agent deployment. If you've been working with tools like LangChain or LangGraph, you already know that incredible feeling when your code finally clicks and works. But taking that local script and getting it to run for actual users in the real world, well, that requires a completely different set of skills. Okay, so let's really dive into this because this is exactly where so many developers just hit a brick wall. You spend hours crafting the perfect prompts, you set up your nodes, and your agent is running beautifully on your own machine. But what happens when 50 people try to use it at the exact same time? How does the system remember what user A was talking about versus user B? The gap between building an agent locally and actually deploying it into a production environment is massive. And that's the exact gap we're bridging today.
Here's our roadmap for the explainer. We're covering 1. The agent's new home, 2. LangGraph server setup, 3. Deployment via Docker, 4. Understanding threads and runs, and 5. API and testing. Let's get to it.
Section 1. The agent's new home, infrastructure and environment.
The harsh reality is your agent absolutely cannot live in a local Jupyter notebook forever. Think of your AI agent kind of like a human worker. A worker can't just float in a void and do their job, right? They need an office, they need a desk, filing cabinets for long-term memory, a notepad for short-term memory, and a system to juggle multiple requests. An agentic infrastructure is exactly that. It's the environment that handles all the heavy lifting, things like storing chat histories, keeping multiple user sessions totally separate, and managing background tasks. That way, your agent can actually just focus on reasoning and executing its job.
So the really good news here is that you don't have to build this complex office from scratch. LangGraph Server gives you this entire architecture right out of the box. It acts as the orchestrator managing your workflows. It pairs perfectly with Postgres, which serves as the database for both your short-term and long-term memory. And then it brings in Redis to handle task queues and background processes. Honestly, instead of you having to write custom logic for multi-user authentication and database routing, this setup just handles the whole shebang for you.
Section 2. LangGraph Server Setup, Configuration Files. Now for the actionable stuff. To get your local code ready for deployment, you need 4 specific files in your directory. First, obviously your actual Python agent code. Second, a requirements.txt file for your dependencies. Third, a .env file to hold your API keys securely. And finally, a specific configuration file called langgraph.json. Think of these 4 files as the ultimate bridge between your local setup and the production server. Let's actually look a bit closer at that langgraph.json file because it's absolutely critical. When the server first spins up, it literally has no idea what your code does. This JSON file acts as its map. It explicitly tells the server the path to your Python file, and more importantly, it points to the name of the compiled graph variable that serves as your starting point. It also locks in which Python version you're using and tells the server exactly where to find those environment variables.
Section 3. Deployment via Docker, building the container.
All right, to actually deploy this thing, we need a Docker container. Thankfully, LangGraph provides a command line interface that wraps around the messy parts, saving us from writing totally custom, complex Docker file configurations by hand. You just run a single command, langgraph build-t, followed by whatever you want to name your image. The system automatically reads that JSON config we just talked about, gathers your Python files, pulls in your requirements, and boom, builds a standardized production-ready Docker image. And what's really cool is how seamlessly this comes together on your local machine. A single Docker compose.yml file elegantly strings together 3 distinct containers all at once. It pulls down the official Postgres image for the database, grabs the official Redis image for the queues, and links them directly to that custom LangGraph image we just built. All of this is exposed locally on port 8123. So with just one Docker compose up command, your full agent infrastructure is running exactly the way it will in the cloud. Speaking of the cloud, let's talk about hosting options. If you decide to self-host this infrastructure locally or on your own servers, it is 100% free to run. But if you'd rather not deal with DevOps, LangGraph has a managed cloud platform that handles the deployment, scaling, and the infrastructure for you. Right now, while it's in beta, this managed service runs $39 per month. It's really just a trade-off between managing it yourself for free or paying a bit for the convenience of a hands-off cloud environment. Section 4. Understanding threads and runs, the core API concepts. Okay, so your server is up and running. How you actually talk to it. Let's start with threads. A thread is basically a session context. Think of it exactly like opening a brand new chat window in ChatGPT. Every single time a user interacts with your agent, you create a thread. That thread stores the entire history of the conversation, acting as the short-term memory for that specific user. Without threads, your agent wouldn't even remember what was said 30 seconds ago.
Now, if a thread is the chat window, a run is what happens when you smash the enter key. When you ask the agent to actually do something inside that thread, you're kicking off a run. This is the execution phase. It's the agent actively looking at your input, deciding which tools to pull from its tool belt, and generating a result.
You have two main ways to execute these runs. A background run is kind of like a teacher assigning a massive final project. You assign the task, the agent goes off and works on it silently in the background, and you just have to periodically check in or poll to see if it's done yet. A streaming run, though, that's like watching a student do their homework live, right in front of you. You get to see every single step, every decision, and partial answers flowing back in real time.
And if you do go with streaming runs, the server gives you incredible control over what actually gets streamed back to you. You can stream just the final messages. You can stream values, which spits out the entire state of the agent at every single step. Updates will send you only the specific pieces of data that changed. Or, and this is my favorite, you can stream events. This streams highly granular behind-the-scenes actions like the exact moment the agent decides to open a web browser or hit an external API. If you're building a sleek UI that shows users exactly what the AI is thinking, Events Mode is an absolute game changer.
Section 5, API and testing, connecting to your agent.
So how does your front end actually plug into this back end? The server gives you a few options. If you're building in React, Next.js, or Python, you can just use their dedicated SDKs, software development kits, which wrap all of the complex API calls into super simple functions. You can also use the Remote Graph Protocol. But for most standard backend developers, the go-to universal approach is just going to be the REST API using standard HTTP protocols.
Using that REST API is a very clean, logical three-step dance. Step 1. You send a post request to create a thread, and the server hands you back a unique thread ID. Step 2. You send another post request to create a run. You just pass in that thread ID, your assistant ID, and the user's prompt. Step 3. You send a GET request to either pull the status of that run or to open up a stream and get the live results. Super straightforward.
And the absolute best part? You can test this entire API workflow locally right now. When your Docker containers are running, LangGraph automatically generates full open API specs. You just open your browser, head over to localhost port 8123/docs, and you can fire off requests right there. Or, even better, you can connect LangGraph Studio. It gives you this beautiful visual interface to debug your traces, rewind the agent's steps, and see exactly what the memory and states are doing under the hood.
Well, we've covered the whole journey today. We took a local agent, gave it a robust home with memory and queues, cleanly packaged it up into Docker, and broke down the core API mechanics of threads and runs so you can actually communicate with it. You've got the blueprint now. The infrastructure isn't a mystery anymore. So the only question left for you is, are you ready to transition your AI agent from a local script into a scalable, production-ready system? I really hope this explainer gave you the confidence to do exactly that. Keep building, and we'll see you in the next one.